Okay, it is time. Are you ready? We're going to make Pong in Python. And we have all the tools. We have them all pre-made. We have our paddle that exists and it can move up and down. Well, right now it can only move in one direction, but we're about to fix that, don't worry. And we have squares that can bounce around on the screen and simulate a ball. And that's all you need. Just bring them together in a fancy way and suddenly you have Pong. And we're going to do that. And also, heads up, this is your last programming assignment. Your final programming assignment will be to follow along with this lecture right now. So might as well follow along right now. Let's do this. So let's continue moving a rectangle with the keyboard and making this work. So I have got pong.py open, and I'm not sharing this with you because you're going to write it yourself, okay, for your programming assignment. And I have the stuff from last time. I got our bouncing square and moving rectangle. So let's do the moving rectangle at the moment. And let's remember what that does. Boop. Yay, we've got a rectangle. It is a moving. Can't go up right now. Let's fix that. So all we have to do there is say, oh, let's make a go up function. That gets called whenever we press the up arrow. That's not too bad. Yeah. Alright, offset can still be 10. Turtle go up by an offset. Plus offset. And I can say on key press up. Hey Turtle, you're listening. I've made sure that you're listening for my key presses. When I press the up arrow, the up key, please run the go up function. And so every time I press the key, or if I hold it in, it's going to keep getting called repeatedly, because that's how key presses work on computers. I'll just keep calling this function to change the turtle's y coordinate by a positive amount, and oh man, will that change it. So I can go down now, and I can also go up. Beautiful. Okay, we are almost home free. The paddle is not within the coordinates of the game at the moment, so let's work on this. So now it's time for Pong, and I've just written a lot of stuff that we're going to do. So the first thing to do is we don't want the turtle to go out of bounds when he hits the top or the bottom wall. We want him to stay within those bounds. Okay? We should also put him like within the bounds of the screen as well. So let's do this. So the idea is, well, the turtle right now, he has coordinates, and remember that every turtle has got coordinates right in the middle of himself. So we think he's on the edge, but he's really not. He's got pieces sticking over. Okay, so how wide is the turtle is the first question. How wide is the paddle? So paddle width is, going back to this program, I stretched out the turtle, and I think the default size is 2020. So this would be, he's going to be width 30 and height 120. That is our paddle. So if we need to bring him in, we need to bring him in by 15. Yeah? So let's do that. You can say, just say go to probably. Let's get his XY, I guess. Remember that turtle.pause goes and gets, I don't know if I can show it to you. Where is the side? Everybody's using it, but nobody's showing you what it is. Turtle.position. How about that? There we go. Turtle.pause or turtle.position tells you the current location, XY, as a tuple. There we go. That's all I wanted. We found it. Okay, so I'm going to use that. to go and get the x and y coordinate for the turtle and move him inside the screen, so we got to put him a little bit down. Go to like x plus, I don't know, where is he right now? Probably in the middle, so how about go like 80 down in the y direction and like, I don't know, 40 over in the x direction. Let's try that. That's looking alright. Maybe we can bring him a bit closer to the wall though. This is just a game of picking the right numbers. Let's try 30. Offset the x by 30. And we can bring the paddle maybe into the middle by doing minus a little bit more. Minus, I don't know, 110. That seems alright. So that's our starting position for the paddle, and so now he's starting within the bounds, but we got to keep him in the bounds. So if he goes up too much, we want to stop him. Okay. So we can deal with that in the go up and the go down functions. We can say, all right, before we tell him to go anywhere, we got to keep him inside the screen. If the turtle is going off the edge of the game board, put him back. Put him back inside. And we can make a variable that does this. And a really funny thing about that cryptocurrency lecture from last week is that I have a bunch of YouTube bots commenting on that one video. So I have a ton of spam comments on that cryptocurrency video just because it's like a buzzword, which is hilarious. Okay, so back to the program. Turtle.go to not y minus offset. We need a new y position. Like our y position is about to be y minus offset unless we hit the wall. Let's do this. New y. Y plus offset can be new y down here. So I'm just storing like what we're about to do in this new y variable, and if everything's okay, we'll keep it there. But if we hit the wall, we need to keep the turtle back inside of his bounds. So here we are at the wall. If we are about to go a little bit above it, we need to bring the turtle back down to like just graves the wall. You see that? So that's what we need to work on. So if you're going down, you can only hit the bottom wall, in theory. So let's fix that. If the y coordinate for the paddle, if y is less than or equal to, now we need to know what happens if we're off the end of the game board. And so where is the middle of the paddle if we're about to hit the end of the game board? Remember that this is going to be like y equals negative 200. So here's like the bottom screen. We want to be like, okay, here's y equals this line right here, negative 200. And we want to stop the paddle if he's negative 200, I guess minus half the width of the paddle, half the height of the paddle, so minus 60. So we got to stop him if, stop the paddle if his y coordinate is 200, negative 200 plus 60. I hope that makes sense, because the turtle is in terms of the paddle itself. So let me show you if we don't do that. Like if it's just, okay, it's less than negative 200. I don't need these parentheses. We can say, okay, just set him back. New y equals negative 200. And this is not quite right, because the turtle is going to run off, because it's always, we're talking about the middle of the turtle, not the edges. And do the same for this one, but greater than or equal to. And so the problem now is the turtle will stop. Like, he's not going anymore, but it's all relative to the middle of him. We don't like that. So let's fix that. We can say, okay, when is the middle of the turtle about to hit the wall? And that's when it's the wall's coordinate minus half the height of the turtle. at this point. So let's make that work very quickly. So it's going to be negative 200 plus half the height of the paddle, 60, 60, and then this is going to be minus 60. And suddenly we are stopped right at the top. Beautiful. And we should also be stopped right at the bottom. Okay, so that's our code. It's looking good so far. Now we need to worry about bringing in the ball. Okay, so let's deal with the ball now. It's not as easy as just, okay, let's copy in the code we wrote from last time to bounce the ball around, because the turtle is the paddle. Remember, we're using the turtle as the paddle right now. But we also need the turtle to be the ball. Ooh. The answer is, and the solution is, you can have multiple turtles in your program, which is weird. You just have to give them variables now. So you can't say turtle.goTo or anything else like that. Now you have to say, hey, my turtle, its name is this. Its name is paddle. Make a brand new turtle, okay? Turtle.turtle, with a capital T, is a function that makes a turtle. You can think of it like that. So now we have to say paddle.goTo instead of turtle.goTo. So let's do that, and then we can finally add the ball separately. So we're going to make two turtles, is the idea. So this first one, we need to make the ball. And I guess we can keep them like this. Make the ball. Sorry, this is the paddle. Excuse me. Paddle equals turtle dot turtle. Okay, brand new turtle for the ball, or for the paddle, excuse me. Now, everywhere that I say turtle, I have to change to paddle. So, here, paddle, paddle. I've changed his size and things like that, his shape. This is all paddle stuff. I can actually move this up here. I guess, no, I can keep it down there. Why not? Why not? So, yeah, this is the problem. All this stuff has to be paddle now. Everywhere I said turtle dot, I have to say paddle dot and work just on the paddle. So let me pause the program, or pause the video, and go and do that. Okay, I'm almost done. Gotta do it in the draw rectangle function too. All the turtles need to go away. I think I've set it here. Let me just make sure if I search for turtle, it's never any code, except for the very top line. Yeah, that looks good to me. Oh, there was one. That's why we do this. Turtle, turtle, turtle. I think we're all right. All right, so this should mostly work. If we go and run it. The issue now is turtles themselves don't have on-key presses. The turtle module did. I know it's weird to think about, but the turtles themselves don't. So the key presses, they need to be registered with the screen, not the turtle now. So that one thing that I didn't want to do last time, we have to do now. So if we just say turtle.getScreen, that will give us the screen for the program. And from there, we can listen for commands. And what the screen is it's just this window. That's what the screen means. We're going to have multiple turtles, and so we need to, and just one screen. So that's why it forces you to separate it all out now. So turtle.getScreen is screen, and now I'll just say screen.onKeyPress and screen.listen. There we go. So now everything should be the same, and it should work just fine. We actually have, in the very middle, you see that there's the default turtle, and he's just chilling, facing right, facing east, with his default view of himself, a little arrow. We can hide him. We can say, turtle, hide the default turtle. Turtle.hide turtle, which is funny. Now he's gone. Okay, now everything else works as normal. and we can bring in the ball at this point. So where's the ball? It is sitting in bouncing square.py from last time. You can copy all this in. So now I need to make the ball. So ball equals turtle.turtle. The ball's speed and shape can be, I guess we don't want him to be a turtle anymore, but we can make him fast. I don't think that matters anymore because we're just using goto, but that's okay. Keep him around for fun. We don't need that. We did that. We need to make the ball a square, double the ball's size. So we say ball.shape, ball.shape size, ball.fill color. Let's make him blue or something to differentiate him from the purple, or I guess violet paddle. And then we need to put the ball at a random spot. We can do all this down here. So after we've listened for key presses, now we can do ball stuff. Well, we can pick the ball up. We can go to a random location, things like that. All right. Are you ready? So it's going to be ball.up. Ball.go to that random initial location. Give them initial random direction as well. So I'm going to copy all of this. That's the rest of the game. Paste it in. And again, I need to go and see, okay, every time I said turtle, I need to put ball instead. So I don't see turtle here. I did ball here already. This last one, ball.goto. Okay, so I think that's all right. Let's make sure. Blue ball and something paused the program. Why did it do? Oh, because it's asking us, oh, how fast do we want the turtle to go? Let's just hard code that this time. Oh, let's not worry about that for now. Let's hard code because we asked, hey, how fast do you want the turtle to go for this multiplier? Instead, we can just give it like 2 or something. Boop. Multipliers are always 2. Don't have to ask these or anything. Cool. Now we have ball bouncing and a paddle moving. And a fun little quirk of Python is that if we ever move the paddle, it's like it makes the ball go slower. It's a little bit beyond the scope of this class to talk about why, but that's a fun little side effect. And yeah, now the issue is the ball and the paddle are not aligned. So we got to fix that. Okay. But this is fun. I mean, it's working. It's bouncing. And the paddle's moving. We just got to hook them up together. Got to put them together somehow. Okay, are you ready? Back to here. What do we need to do? Okay. So we made the ball. And let's do the game over bit first. If the ball ever hits the left wall, it is game over. So let's go and hook into that case in this while loop, if you remember. Bouncing off the walls. Oh, what do you know? Thanks for that comment, past Lawton. If the turtle hit the left wall, well, the game should be over. Let's just say that. Let's print game over. We can just let it keep going, though. And, yeah, if the turtle ever hits the left wall, we can say game over if we'd like. And so every time it hits the left wall, it'll just print to us, game over. And apparently it's going to go very slowly because of the random direction. There we go, game over. If I rerun this, it might do it a bit faster. So now I've got, oh no, of course not. You can do it, pick a random location that is not straight up and down, almost. There it goes. Yeah, so it's going to print game over down here every time it hits the wall over there. And we can have it stop the program too. It doesn't really matter. That's the easy bit. We have game over now. And the final piece of the puzzle is to bounce off of this paddle. And that is the hard part. Okay, we have to do a lot of math. It's all going to be hard-coded silliness, but it's all going to be worth it. I can promise you that. So you make the ball bounce off the right side of the paddle. And here is the idea. Okay, it's a bit involved. I have to draw this. So when does the ball bounce off the paddle? So remember, here's the paddle. It's got an XY coordinate, so it's got like X paddle, or let's call it paddle X. It's got paddle X and paddle Y as its position. And its width and height is 30 and 120. And this spot right here is paddle X, paddle Y. And the ball, which is a rectangle, it is, if I can just draw it really close, it's got its own ball X, ball Y. That's in the middle of it. And it is, what, 40 by 40, I think. So, whatever shall we do? How do we know when this ball hit the paddle? Like, it's coming this way, it's about to hit the paddle. How did we know that? And here is the idea. There is like a line of sight that the paddle can see. We need to test the ball's coordinates somehow. And the test is quite important. It's quite lengthy. So how do we know that the ball was about to hit the paddle and not just like fly past it? Like maybe it's down here. It's about to fly past the paddle. Well, it needs to be within the range that the paddle can reach. So take the paddle's, this is all Y coordinates right now. Take the paddle's upper Y coordinate and lower Y coordinate. Make sure that the ball is within those. Okay, so that's the first rule. This is ball Y. For this one, for this upper limit, it needs to be, I think, we want to say less than or equal to. It needs to be less than or equal to the paddle's Y, which starts here, remember, this is the paddle's Y currently. It's always in the middle. Paddle Y. And then it's the height of that plus 2, because right here is the paddle's Y. We need to get all the way up to here. That's plus 60. That's the width over 2. Divide it in half like that. And then also, I mean, that would let us get the ball to hit off right here. But I'd also like the ball to hit off if it's just a little sliver at the top here. So let's also go, additionally, half the height of the ball. So plus 20. Because otherwise, the ball would only bounce if the middle of it, this is like the last time it would bounce. If it went just a little bit more up higher, it would have gone past the paddle otherwise. I hope that makes sense. But we want it to, like, if it's just touching the top, we want it to also bounce off. Okay, so that's why we give half the height of the ball as well. Okay, so that's the top one. The bottom one is symmetric. It's if the ball's Y, it needs to also be, like, it needs to be within these ranges. So it needs to be less than this, but also greater than this. It's paddle Y minus 60, because this is the Y, this is the Y minus 60. And then we need to go a little bit farther, half the height of the ball, minus 20. Okay, height of the ball over 2. This is paddle width and paddle height over 2. This is the ball height over 2. Hopefully that all makes sense. It's a lot of computation, I know. So that's how we know we're within the range. But I mean, maybe, yeah, we're within the range, but the ball's way over here. How do we know when we hit the paddle here? We now need to consider the x coordinates. Okay, so bear with me, we're almost there. The x coordinate of this ball better line up. It better be very close to the x coordinate of the paddle. You see that? So if it's just touching this, what is the x coordinate of the ball? It needs to be well, whatever the paddle's x-coordinate is, plus half the width of the paddle, plus, if it's just touching, the middle of the ball is going to be right here, yeah? It's going to be along this line. And that is the x equals whatever line. X equals paddle x plus 15 plus 20. You see that? So we've hit the x-coordinates align if the ball's x, like it's tried to go a little bit past inside the paddle, it's bouncing off. If ball's x is less than or equal to the paddle's x, oops, sorry, that's my alarm going off. If the ball's x is less than or equal to the paddle's x plus the width of the paddle over 2 plus the width of the ball over 2. So that's plus 15 plus 20. Okay? If all of these things align, then, only then, we have hit the paddle. We've hit the right side of the paddle. That's a lot of stuff. That's very involved, I know. But all we need to do now is put this into code, and suddenly we have a bouncing ball. Okay? All right, so here's what we'll do. Let's make a function to check this, because the turtle needs to also bounce off walls and the paddle. Okay? So it's going to be this loop that we're going to change. And we'll just add another if statement. So check if we hit the paddle. If so, bounce off of it. So I'm going to do what is probably one of the greatest properties of programming. I'm going to make this a problem for future me. And we're going to package this checking into a function. Okay, this is the exact kind of thing that you should do when you're writing your programs in the real world. You will say, well, if, hey, did we hit a wall? And if we did, like, did the ball hit the paddle? That'll return true or false. If it did, let's bounce off, okay? Bounce off it. Else, well, we don't have to worry about the else. Okay, so how do we bounce off the paddle? Remember, we're coming, like the ball's guaranteed to be coming out this way. We got to bounce it off that way. We need to change the x coordinate of the direction. Okay? Yeah, that's not the right thing. So it's just like one of these side walls, just like the left wall essentially. We bring them back on the correct side of the wall, and then we also negate the x offset. Correct side of the paddle in this case. So where in the world is the paddle? Like, where's the correct side of the paddle? Where is just touching the paddle? And that is when the x is equal to paddle x plus 15 plus 20. Okay? So that's this one. It's boop, boop, boop. Is that what I wanted? Yeah, paddle. We're going to set the ball's x to be exactly that, I think. Let's confirm that. We'll say we gotta get the paddle's x and the ball's x. So paddle x, paddle y equals paddle dot pause, and then we'll do the same for the ball. So like the new location x, the new coordinate for the ball is about to be whatever whatever paddle x is plus 15 plus 20. I think that'll work. We will make it work. If it does not, I might be off ever so slightly. But that's what I think needs to be the case. And with that, we got plus 15 plus 20. I think that'll be right. Now we just need to worry about making our did the ball hit the paddle function. So let's make that. So we say def. We can do it up here maybe. def did the ball hit the paddle? Well, let's get the locations of all of these things, just like we did here. Oh, sorry, this is balls. Pause. Let's make sure we got that right. I guess technically we didn't even need the balls location for that one. So we've got both of their positions now, and now we just need to return true if all of these three things are true. Okay? So it's just going to be one big if statement. So if lots of stuff like lower than upper part of paddle, how do I want to say that? Upper boundary, like below upper boundary. Let's call it that. So the ball is below the upper boundary if this is true. So that is going to be true or false depending on whether ball y is less than or equal to paddle y plus 60 plus 20. And then same for the other one. This is going to be above lower boundary. The ball is above the lower boundary if this is true. If it's greater than that, minus 60, minus 20. And then finally, it's if the x-coordinates align, like it's past the ball is past the paddle, or touching it. Is true if the ball's x is less than or equal to paddle's x plus 15 plus 20. Okay, so if all these things are true, if below upper boundary is true, and above lower boundary is true, and touching or past the paddle is true, if all of those cases hold, then we've actually bounced, okay? Yes, it did. Yes, the ball did hit the paddle. Return true. Otherwise, return false. Okay? So, I might have gotten some numbers wrong. We'll go back and I'll re-explain if I did. But this is our last case. We checked if the ball hit the paddle. If so, bounce off of it. Kind of did something. Let's see if it hits it. Oh, yeah. Oh, that's nice. There it goes. There it goes, guys. Look at that. It's bouncing off the paddle. And if I don't let it hit off the paddle, it's game over. The very last thing that you could do is stop the entire game once it becomes game over. So let's work on that. Just got to go back to the code, and this is the game over bit. We need to change that ever so slightly. So all that needs to be done is to stop this loop, but not actually close the program. So because this is a while loop, a for loop, this would also work. There's a way to end the loop early. I mean, this one's never going to stop because we said while true, but there's still a way to stop the loop. And that is to use the break keyword. Okay? So let's see here. That means this code will never actually happen anymore, but maybe that's fine with us. So if we say break, that's going to stop the loop. This breaks us out of the loop, and the loop stops. So we start immediately executing the code that comes after the loop, but there's nothing, because that's the rest of the program. And so that will end the program a bit more gracefully, I think. I used the quit before, but that was like showing me weird errors. It's like, hey, do you want to stop the program? No, this is a bit cleaner. So we can just say break, and that will stop the loop, which will make the program go to the end, but not like give us weird error messages or anything like that. Okay, so that's all. Now we can play the game. Looks like it's gonna be a while before this gets to the top, but the program will stop now. The loop is going to stop. The loop that moves this block, this this ball, it will stop, given that break statement, whenever we hit the left wall. Okay, so let me fail to catch the ball, and now it will stop because the loop stops. So remember that this loop was moving, it was moving that ball, and because we broke out of the loop, we now have no ball left to move. There's nothing left to do. Technically, up and down still works, but the ball is no more. The ball is no longer moving, and so you have to restart the program to play again. Okay, that is all. That is the entire program. We did it. We made Pong together by bringing in all the stuff that we had before. Our two little bits, our paddle bit and then our bouncing block bit. And we combined them together with some fancy math, and we built a complicated program together. So we did it. So your final programming assignment is to just copy what I did. If you don't want to think any more about it, you got to copy it. You have to explain it in your video. So you have to understand it somehow. So please come to office hours if it's not making any sense. But just follow along this video if you weren't already and recreate this. Recreate Pong with me. And yeah, you can change this game as much as you want. Different colors, you can make cool things happen if you feel like it. But just make sure that you keep all the features that we implemented. Maybe you want to add a player too, who knows. But yeah, this is all that is required of you. So go crazy if you'd like. And yeah, upload a video as usual. This is your last programming assignment. So it will be due the last week of classes on the Thursday when our programming assignments are normally due. And yeah, just explain your code to me. I know that you were probably following along, so I really want you to prove to me that you understood it. So walk me through how your program's executing as you explain it, as you demonstrate it. Okay. So I think that's all. No more programming assignments for you, and no more essays either. I gave you that one last week. So you now are ready to just relax a little bit before the final. So that's all I got for you, and I will see you next week.